Hello everyone, welcome to Codecrafters Lab. So today we are going to see the basic maths problem, which is check for perfect number. So let's try to understand this problem. So here we are given with integer n and we want to check if the number is perfect or not. We have to return true if it's a perfect number, otherwise return false. Okay. And what is a perfect number? It is a number whose proper divisors add up to the number itself. Okay, so in this case n equal to 6, that means there are three divisors. One, we can divide 6 by 1, which is a perfect divisor, then 2 and 3, right? So which is equal to 6, so that's why we will return true in this case. Then in case of 4, it is 4 1 2, which is 1 plus 2 equal to 3, that's why false. So in case of 128 it is 1 2 4 7 and 14, which is equal to 28, right? So that is why we will return true in this case, right? So let's try to understand this problem's pseudocode. So let's say our n is equal to 28 maybe, right? So what we have to do here, we have to find the number which are perfect like divisors and we have to add them, right? And the without adding up that particular number, right, we have to exclude 28 and we have to add other divisors, right? So how we can do that? So basically we have to run one for loop here. We will take one int sum variable equal to 0, then we will run one for loop for equal to 1 till I is less than n and I plus plus, so that we will try to get all the numbers below 28, right? So after that what we will do, we will do if n modulo I equal to 0, so it will give you the remainder 0, that means the number is divisible by that particular ith number, right? So if it is, then what we'll do, we'll do sum equal to sum plus I, right? We will add sum plus I, right? We will add ith number, and at the end what we will do, we will do if n is equal to sum, that means the number is equal to the sum that we got, then we will return true in this case, or else return false. Return false otherwise, and we will close this for loop here. We can close this here itself, right? We don't have to close it here. Okay, and let's try to understand this. Basically we have taken we have taken n equal to 28. So let's say when my I is 1, in that case it is divisible by I, this condition will be true, so sum will become 1. Then in case of 2, this condition will be true, then sum will become 1 plus 2, it will become 3. Then again in case of 3, it will not go inside this loop. Then in case of 4, it will go inside the loop, so my sum will become 7. So that is how it will go on, and we can have our sum variable as our like we have to basically compare our sum with the original number. If it's equal to if it's same, then we will return true, otherwise we will return false. So this is the pseudocode, and this is like a brute force approach. Okay, and what is the time complexity in this case? What is the time complexity? We can say O of n, because we are running this for loop from 1 to n. And space complexity, it is O of 1. We don't have any other variables rather than constant space we are taking, right? So let's try to code this here. So here int sum equal to 0, then we'll write one for loop for int I equal to 1, I is less than n, I plus plus, right? After that what we'll do, we will do if n modulo I equal to 0, if it's true, then we'll do sum plus equal to I, otherwise we'll do nothing here. Then we'll do if sum equal to n, return true, or else return false. Let's try to run this. Yes, it's accepted. So this is like a brute force approach for this particular problem. We will try to see another approach as well, which is more efficient. So let's dive into that particular solution in the next lecture. Thank you for watching.